So I can calculate the area of parallelograms and triangles. Those are for both 6th grade standards, which is good. That gives us a little bit of review for today. So here's the first review. The area of a shape. This is the very top, the very first thing. The area of a shape is literally the number of squares it encloses. The number of squares on the inside. Did you find it? Very top of the page. When someone is talking about area, it's literally how many squares are on the inside. Which means you label it in units squared. So it might say centimeters squared because you're counting squares. It might say feet squared. It might say miles squared. Literally how many squares will fit inside. If you have a house, you would know how many square feet you have. You could literally on the floor take squares to see how many squares cover your floor. Or your apartment or your townhouse, whatever it is. Same thing for the grass. You would know how many square feet of grass you have outside. So I could count them. Eight square units, square centimeters, square inches, whatever we're measured in. Or, what if I don't want to count them? 1, 2, 3, 4, 5. I mean, that's going to get kind of big if I'm doing my house. What, Ellie?
Can you times the sides?
Oh, yeah. I could take the base, which this one is 4, times the height, which this one is 2, to also get 8. So I can count every single square there is, or I could just take the base times the height, which is the official formula that Mr. Lefebvre or Mr. Heil or Mr. Johnson taught you. Did anybody want to write down the official formula?
Can you write down the ordinate?
I don't think you do. So just like 100 other days, B is going to hop out, your base number is hopping in. H is going to hop out, your height number is hopping in. So here's our first box. Base hops out. What? That's not the base. Oh, it's a rectangle, so whatever the top is, the bottom. Oh, yeah, okay. H hops out. 2 hops in. What's the area? 6 meters squared. When you haven't practiced something for a year, you're probably going to forget the labeling. So if you notice your neighbor doing that, use your nicest voice and say, hey, don't forget the squared. Here would be a not nice voice. What are you doing? It's supposed to have a 2. Use your nicest voice. Second box is our twist number 1. It's tempting to do 2 times 2, except Except, Mason,
It's in yards.
twist number one. They have to be measured the same.
So isn't it 6? Yeah, it should be 6 feet.
Oh, so some people are remembering 1 yard equals 3 feet. So 2 yards equals. Okay. Look at that. We outsmarted that one. Base hops out. 6 hops in. Height hops out. 2 hops in. 6 times 2 is 12 feet.
And then could you see
Where?
into yards? 4 yards squared.
Oh, sure. Both answers would be correct. Technically, we could have changed this feet to yards, but it would be a fraction or a repeating decimal, and a lot of people go, oh, I don't want to do that. So the whole number one was a tiny bit easier for this one. In that next box, don't write this whole thing. We need this word altitude. And here it says the line segment perpendicular. Don't write that whole thing. Perpendicular. Perpendicular. Pete! Thank you, sir. I do think you should write this blue part that I just wrote. Altitude. 90 degrees to the base. Is your altitude box filling up? 90 degrees to the base. Because twist number 2 happens in the next problem. When the parallelogram becomes tilted or pushed over, we're probably going to have some extra information. And how do we know what is extra? Allison?
What's in the middle?
That is what a lot of people think. Think of what Pete told us.
Isn't the extra 30?
Why?
Because you have to have it even or slanted.
Think about what Pete told us, what we wrote down in the altitude box.
77 is like arrows. Oh, it's 90 degrees to the base.
Thank you, Ellie. It has to be 90 degrees with the base. What is 30 inches making 90 degrees with?
Say nothing.
Nothing. It's distracting us. Get that 30 out of there. It is literally called a distractor. Yeah, cross it out. So now base hops out. 77 hops in. Height. What should we do with the 30?
Nothing.
Nothing. This is a really good one to practice the multiplying on. Two by two multiplication. That's 3rd grade stuff. Do you have a side problem going? Drake? Did you get that?
No.
Pete?
1,694.
Yes. Drake, I thought you were doing ice cream shop stuff.
I know. My parents changed it so we leave tonight.
Actually, I like that better. One more day you can be here. How should I label it? Inches. Squared. We're gonna forget. That's why we're just trying to remind each other. We're out of practice. Did you know your brain is like a muscle? You have to work it. You have to make it do something in there. Bryn.
I went to the doctor last night and I had to get a shot, and like when we got in the car, I was like, I watched her put the needle in, like I told my mom that.
Ooh, that was great.
Yeah, it like goes right into your muscle, and I like freaked out. I was like, what? That goes into my muscle? I did not know that. I thought it goes into your muscle.
And then all the blood cells come and grab the parts of it and start spreading it around your
I
body.
did not know that. I thought it just went into your like,
Science right in front of your eyes, Bryn. What was that altitude thing we just wrote down? 90 degrees to the base. So can we get rid of something? Addison? 2 is distracting us. It's distracting us. Get rid of that distractor. What hops in for base? 3. What hops in for height? Exercise your brain a little bit. I like to put the longer one on top, not the bigger one. How many decimal spots? 1. How do I label it? Feeling good?
Oh gosh.
Excellent. Twist number 3. What if they start erasing parallelograms from my parallelograms? Like there used to be, I lost my black. There used to be a solid black/gray parallelogram there. What if it was just a solid gray/black rectangle? Bryn?
Then neither of those times are good. It just 65.
Okay, so my big rectangle would be just 65 times 30, right? But then, what about the 10s?
Oh, because those are just the length of the little, how it goes down, it's just the length of that line.
So if I was going to find the whole thing, do I use it?
No.
No, it's distracting me. We'll talk about when we can use it. That's distracting me. Don't use that. Now someone comes along. Just erased part of my parallelogram. How dare they? Think about what math word could go with erase.
Minus.
Minus or subtract, exactly. So I have to take away.
Some of the days.
65, 30, 15, 45.
What?
15, 45.
15 times 45, right? Someone came and took this parallelogram away. Why would they do that to me? So if I find those two numbers and subtract them, I will know just the gray part. Use that box below. It's empty if you need. Nope, I'm gonna multiply 65 times 30. And then I'm gonna multiply 15 times 45. And then I'm gonna subtract my two answers.
Yeah.
No, I had a black, and then I moved it somewhere. But I don't.
You can just use your other blue
Just use your
marker.
blue.
Get in your pockets.
No pockets today, but that is a good spot.
It's right there.
That's
right
blue. That's a blue one.
This is my backup blue. I mean, it'll work. There was a black one about 10 minutes ago. Just getting too excited teaching parallelograms around here.
Did you put it like where your spray is usually? Or like where you can
Found it.
I'm smart thinking.
Problem solved. Hey, did anybody do this trick for 65 times 30? Not that trick.
65 times 3 out of 2.
Yeah, that's what I was thinking. Look how much easier that looks. One 950? Anybody? So 15 times 45, I'm just gonna have to tough that one out. 675? Anybody? 675?
Study?
And then what?
Subtract.
Minus.
1, 2,
Subtract.
1, 2, 7, 5.
Borrow. This is really exercising my brain. 1275?
Wait, why is that? Why is that? Is that the 81?
That was my messy borrowing. That was a 14.
Oh. What's a 81?
I see why they make me do this one. They think, they hope that I'm gonna give up in the middle and not solve all the way to the end. But I will not give up.
They underestimated us for sure.
For sure.
Oh, so.
Could there be a way or a reason to use the tens?
If you wanted to.
You add them and then subtract them?
Instead of someone subtracting parallelograms, you could take that parallelogram plus this parallelogram plus this parallelogram and Bryn,
I have a different thing. Couldn't you also add all of the other kind of perimeter?
you could find a perimeter totally. That would be another reason to use 10. Yep. What if this was like your little cousin and was building things with bricks? So this one would be, yeah, Ellie, 15 times 10.
150.
And this one would be 15 times 10. And this one would be,
55 times
45.
15.
No.
wait.
Yeah, it's 65 times 15 because half of 30 is 15.
What would I do after I found each piece? I heard half subtracting and half adding.
Subtract.
Yeah.
Add. Subtract.
Because I'm kind of stacking, picture Legos. You stack this one, plus this one, plus this one. Guess what I would get?
On 27.
Same number.
Oh,
Which strategy is better?
They're both fine.
neither.
Both good.
Neither.
Here's a strategy that's not good.
What's the answer?
Counting ceiling tiles. That is not a good strategy. So you gotta do something. You gotta do something. Ready, go.
So your strategy is right to be tracked.
I just put 396. That's what.
I'm going to get that money that you said. I know all of them are I know 11.
So far I did 14 times 14. Did you do that?
No.
Hey.
I know.
Sure. Should I add these?
So it's like someone came and punched out the middle of my square. So what's missing from it? So if the whole thing was 196, take out the middle part, label your square. Do you know what's better than learning about parallelograms?
I can tell you. There's nothing.
Oh
No.
Okay,
Is that tomorrow or today?
right now. Look at this square.
Oh, yeah.
Now look at this square.
It's still squares put back together. Tape works.
Still there. What just happened?
It's not there.
Cut it in half. It used to be a parallelogram. Now it's a triangle. How did we get the triangle? You cut it in half. Guess what the area formula has for a triangle? Base and height we had 2 minutes ago. Until I got out my scissors, and now we have half. Are you ready?
What are we supposed to write? Or where?
Next page. I told you what's better than just parallelogram. A parallelogram and a triangle.
Hate triangles.
The only thing that changed is my Angie?
Is it 9?
Put a half in there. Did you write it down?
Yeah.
Ooh, I skipped that word altitude.
Altitude of the triangle.
Altitude?
Something, I don't know. 90 degrees.
90 degrees.
No.
Let's write it one more time. Do you know it's a proven fact? The more you write things down, the more you remember it.
Where do we write?
Right on the top. Oh. Altitude of the triangle. What about it?
90.
90 degrees
I can't see. Of the triangle.
to the base. Look at how silly triangles are, though. Sometimes the height isn't even on the outside. Triangle is so silly. Look at this height. Goes right through the middle. How do I know that's the height?
I choose the line.
Makes 90 degrees with the base. Look at this height over here. What's it doing way out here? Oh, I see what it's doing. It's making 90 degrees with the base. So what if there's a number over here on the slanted part? Bryn, what if there's a number over here on the slanted part?
It's a distractor.
Distractor, get rid of that thing. What if there's some numbers over here on the slanted part? Distractors, get rid of those things. What happened to my parallelogram?
They came back together.
Cut it in half.
It's broken.
Base hops out. 8 hops in. Height hops out. 3 hops in. 5 is sitting there saying, use me, use me, use me, use me. And we say, no, you are distracting us. So this is kind of nice. Since it's multiplication, you have a couple choices. Godiva might pick half of 8. And Drake might pick half of 24. How do you get 24? Oh, Drake says I'm going to do the whole numbers first. Godiva says I know half of 8 really easy. Guess what's going to happen after that? They're both going to get the same answer. Half of 8. 4 times 3. What's half of 24? 12. Same answer. What's my label?
Centimeter. Centimeter squares, I think. Would you say?
I could put 12 little squares in there if I wanted, but most of you would say, I don't want to. Base hops out. 8.2 hops in. Height hops out.
1.8 times 8.2.
How do you know I'm not going to use 4?
Because it's
Not outside.
Not on the outside.
That is not important.
They're not making 90 degrees to anything. 4 and 5. Stop trying to trick us. I think I might do half of 8.2. Whoa, that was easy. This is a good time to exercise my brain. 4.1 times 1.8. 73.8? Yeah, look, line up the dot and get it all you got.
2 dots, so just 2 decimals.
Oh, wrong rule. 1, 2. 1, 2. Feet squared. What's the altitude again? Good question. So what's making 90 degrees on this one? What's making 90 degrees? The 5 and the 2. 5.4, get out of here. Stop distracting me.
She's such scared me. I'm a loud phone.
Just seeing if you're paying attention back there.
Mr. Madison is so quiet.
This is Liam. Sorry? I don't know what they're asking for, but I don't think it's someone here.
So 10 and then half of 10 is 5. So.
Oh! You could do 2 times 5 first? Did anybody do half of 2? I think we're all going to get the same answer. 5. 5 meters squared. In a second, when I say you must set up the problem, here's what I mean by setting up the problem. Oops, that's not what I want. Why would it work when I wanted to?
It did. It worked.
Oh, there it is. Set up the problem. Write down what numbers you're using. Set up the problem. Write down what numbers you're using. I did that every single time. On every single problem. How many did we do? 7 or 8 of them? Set up the problem. Set up the problem. Set up the problem. Did you hear me?
Yeah.
Set up the problem.